Hello everyone, for this tutorial video I like to talk about how permanent magnets work, which are the more simpler types of magnets compared to electromagnets, and as suggested in their title, are magnets that work no matter what, whereas electromagnets only work as long as electricity is flowing through them. Again, as probably suggested by the title. In a permanent magnet, unlike electrical charges, the magnetic charge always possesses two poles, which are north and south, as a reference to how they work in opposite directions of each other. But the north and south poles are independent of the overall length of the magnet. So if you cut a magnet in half, the individual pieces will have a north and south pole for themselves. And if you cut those in half, you will get even more north and south poles, etc. And we can guess that exactly like static electricity, opposite poles will attract each other and like poles will repel each other. And also like an electric field, the magnetic effect happens over a distance or field and is not just through direct contact. So this means that it can pass through materials that do not conduct magnetism as well, such as paper and wood. And also like with electric fields, magnetic fields have specific names for their properties, which is force, for how strong the force is, and flux, for the total quantity of the force. So with this out of the way, if a material that conducts magnetism very well, like iron, is brought closer to a permanent magnet, it will automatically magnetize itself in the appropriate direction that makes it attracted toward the magnet. And any material that is easily magnetized, like iron, is called ferromagnetic, as a reference to the Latin word for iron, which is ferrum. Materials that conduct magnetic fields moderately are called paramagnetic, which is Greek for beside, near, or resembling. So it is near magnetic, but it is not exactly magnetic the way a ferromagnetic material is. And lastly, materials that do not conduct magnetism very well at all are called diamagnetic, which also comes from ancient Greek and means completely, because interestingly enough, a diamagnetic material still does respond to a magnetic field, but in the opposite direction. So it will always naturally repel itself from whatever you pull it toward. And lastly, if a ferromagnetic material retains its magnetism after the magnetization is done, as in a permanent magnet, the physical property that describes this is called retentivity, similar to how the word retain means keep. Now that I've explained the theory behind how permanent magnets work, I can explain how electromagnets work, as those are the most relevant to applications in electronics compared to permanent magnets. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.